Welcome back to lesson number 8. Today we're going to look at discrete versus continuous data, and we're going to start with an In-N-Out Burgers task. You can make it a 3-act task, and that's what I've chosen to do, and I'll explain. There's so many resources for this activity. Second is discrete versus continuous data. This is going to be in your slides, and I also pulled in one little GeoGebra application to use in that. And then finally, graphing stories. This is a classic Desmos activity, and it's a really good way to kind of go back over some of the things they've been learning. So let's start with In-N-Out Burgers. So these are the slides that I produced for the In-N-Out Burgers, and on these, just know you may not want to use them. And to be honest, if you're going to do the task with great fidelity, you probably don't want to use these slides because it kind of tells them more than they recommend. But I'm going to show you these to get you, give you some idea of what's going on, and then show you the different websites you can use. The main creator is Robert Kaplinski, and I'll have his information, his link in here, so that you'll be able to link out to his materials and use his. And then there's another site that's more updated. This is way back in 2004. So the original activity is kind of old, but there are some updated numbers from 2014, and you could even go look this stuff up and use today's numbers if you'd like. But here's just getting them started. What is this? Have you eaten this before? Some of them may have heard of In-N-Out Burgers. We live in the South, so we don't really have these. I guess we do have them, but not everywhere like they do out on the West Coast. And here's the double. What's different about it? What's the same? So again, hopefully they notice the double meat patty. And then here is a 10 by 10 cheeseburger. Is this gross? I think it's gross. Would you eat this? And then I'm asking them to compare and guess maybe at the cost. So again, I'm giving them a lot of direction here, and they don't recommend I ask all these questions initially. So you'll see what I mean when I show you the other resources. And then finally, this is the big one, the 100 by 100 cheeseburger. This is what the whole problem is about. The goal here is to come up with some kind of expression to represent the cost. And then finally, they're going to work with their teams. So what I would do with this problem is this would be a building thinking classrooms task. And I would give them probably something on paper. I know they don't recommend that with those types, but I'd probably give them just the minimal, maybe a picture and a question about what this cost, and then help them tackle that. There are some resources on the website that you could give them for this task. But they will work in teams. I use teams of 3, 2, 3, and 4. It really depends on my number of kids in my class, how much space I've got. I had 3 big whiteboards, so I could fit 6 teams comfortably on my whiteboards, and that's usually what I did, and I would just make it work depending on how many I had in my class. So I'd say most of my classes were 20 something, so I'd have 3 or 4 in each of the teams. 4 is not ideal, 3 is perfect, but in a perfect world, that's not public ed, right? We don't have a perfect world, so we just have to do the best that we can. Once they're finished with their task, I usually just ask them to take a photo of their board work and just insert it on the slide. And these are not excellent photos, but if you haven't been to my site, I do have quite a few photos of kids' work. Some of those I took, but some of those the kids took with their own Chromebooks, and they turned out pretty well. So you can do it either way, but that's how I kind of keep track of what the teams did, is I have them insert photos into their slides at the end. And that's just kind of their documentation. So I wanted to take you to the Robert Kaplinski site to show you where this originated, and I will give you a link to this site, and you can use these resources as is. You might want to do that because he's really good at this, and he made this. So he does have lesson files and downloadable PDFs, and so you can give documents to the kids for them to write in as they're working through this problem. It is kind of fun to work on the whiteboard, so if you've not taken your kids and put them up in those vertical non-permanent spaces before, I highly recommend it. This would be a great one to start out with, and If you have some other way of projecting maybe the pictures of these or some of the resources that you see in here up on the big screen, that they wouldn't have to take things up to the board. They could just focus on the work in the board. This has a situation, and it shows the picture of what I just showed you a minute ago. This is where I got it. Here are the questions or the challenges you could ask the kids to answer. So you might reveal these slowly, as you are going through the problem. How much money does a 3x3 cost? That would be a burger with 3 patties and 3 slices of cheese. I believe that's how these work. And then how many calories, how much money and calories all the way down the list. So you could do one or the other or both. This could be done over many days if you wanted to really get everything out of this. I did set this assignment for 2 days, so I would spend most of one day on this activity if I were doing it. These are some questions to ask kids to get them going down the solution path. The goal here is to get kids to come up with their strategies. Instead of directing them, do this, try this, what do you think? Give them ownership of this and let them do it as much as humanly possible. And then he has a lot of text here. Now here's the problem. Look at these prices. $1.75 for a cheeseburger. Don't we wish it was that cheap still? $1.50 for a hamburger. So these are old prices. I believe it was 2004. Here they have an example, a graphic. And here's a receipt. It's dated 2004. And it's got the cost of $97.66. Another activity, a totally different activity you could do is you could actually do this in multiple years. Like you could do it in 2004 and then do it again in 2014. I've got some updated graphics for that. And then you could even go have them search it out. Okay, what does it cost now? What are they charging for this now? And they could talk about the change in the price over time. So this could truly be extended into a very nice, rich task. And here's the calories. Here's a more updated sign, a little bit cheaper, I guess, or maybe not. I don't know. And here's this one is from 2003. That one's even older. And there's the graphics that I put in your slides. And here's some student work. So they give you examples of low, medium, high. In other words, the low, the kid got some of the ideas but missed out on some big ones, maybe made some mistakes. The medium, they got more of the ideas, but they could have developed them better and given more detail. And then they have high, which means they did an excellent job. They not only put the good information they needed, but they were real detailed and gave some algebraic expressions in here. So anyway, these are your things. Now down at the bottom, I wanted to point this out. The first is the Desmos activity version that he created that basically has a place to put all this. So you could use that. It doesn't have much more than you see on this site, but it does just give them a place to record their answers. I would do the building thinking classrooms and not do a Desmos activity for this one, but that's, of course, up to you. He gave another example. I haven't reviewed this one yet. Jonathan Newman's. This one's a problem-based learning with a very thorough description of what she did. Another person did it in 2 days and showed all that they did. But the one that I thought was pretty interesting, I actually linked out to it, and that was Tim McCaffrey. And I'm going to click here to show you. He actually created a video, and I put this video in the kids' slides in the show notes. So if they have access to YouTube, they could watch it. You could play this for the class. But what happens is this guy is going to go through the In-N-Out Burger drive-thru and actually order each of those things. And then it ends with like the cliffhanger, the 100 by 100. So he's asking the lady, can I have each of those types of burgers? And she does, I think, give him, I don't think she mentions the prices, but anyway. So here's the questions. But he did that to start the task without the pictures, I think, and then he gave them the pictures. So he just kind of approached this in a different way. I thought it was pretty good. And here we have some updated prices. You can see these are all much higher. This was in 2014, so you could probably get a more modern picture and get this one. He also gives some graphics which I really like. If a kid said I bought 100 hamburgers and thought that would be the same, or cheeseburgers, would that be the same as the 100 by 100 burger that only had the patty and the cheese 100 times, but only one bun, and only one tomato slice, and only one onion? And so they could talk about that, and these graphics could help them if they were going down that path, maybe after they've worked on it a while. Here's a new receipt, and he changed it, and the kids were all upset about it. They're like, you changed the receipt. This is photoshopped. So anyway, you could create your own receipt maybe for this that's got modern prices. He has a PowerPoint done. You could click on it, and files done, so you could click on that. So download what you need, and lots of good comments down here. One's from Kyle Pierce, which we've used many times. The 3-act task, he does a lot of those. And Robert Komplinski, who was the original author. Fawn Wynn is another great follow. If you don't follow these people on Twitter, I highly recommend it. So the next thing I have in here is somewhat unrelated, but not totally. In fact, you might actually want to reference this activity again when you get done with this part. And that is introducing kids to the terms continuous and discrete. And we're going to use the slides to do that. So the first thing I did is give them examples of discrete and examples of continuous, and just have them type some things that they're noticing. And of course, the thing we want them to notice is that the discrete is made up of distinct points that are not connected, and the continuous graphs are connected, smooth curves or lines. Both can be linear or nonlinear. Both can increase, decrease, or be constant. So that's not what makes them special, but what does make them special is the way the data is put together. I didn't put a lot of labels on these. I just put one example for each: days since planted and number of flowers. But the key is for discrete is countable, and continuous is measurable but not countable. So you'd measure the height of a rocket in the time in seconds. You would count the number of flowers and the number of days since they were planted and stuff like that. You can measure days too, but not in that particular context. So once they've typed a few ideas here, then we go ahead and use this to further define it. Now, I chose a website that is got such a high reading level that I basically don't want them to use any of the language on this site, except for the labels for the pictures. Let me show you what I mean. They're going to click here. It's going to take them to this site, and it seems like, oh, this is just going to be a direct instruction thing until you start reading this. And it's really kind of funny. I mean, some of this stuff I'm like, really? Yeah, no divisible values, entailing you. Anyway, you can read this. It's kind of funny. I can guarantee you somebody's going to copy and paste from this site, and you will know it immediately because it is so technical, and it's so anyway, that was by design. I don't want them copying any of this text. I want them to do this. This is discrete data. They can read that, and they can see number of eggs in a carton. That they can do. Now, it doesn't describe why it's discrete. Indivisibility of the eggs. They might be able to figure that out. I don't know. Shoes in a closet. Apps on a phone. Tickets for a movie. Number of languages spoken by an individual. So these are all, there's only 5 examples of discrete, and then they do list characteristics, but again, it's really technical language. Most kids are not going to even know what they're talking about. Some might try to, and that's fine. I mean, that'd be great if they read all that, but they don't need to read that. The purpose of this is to get the images and the words. Height, and they've got the little girl being measured. So again, things that can be measured. Time, so they have a clock. Weight, a little scale. And distance. You could also measure the speed. You could talk about that, and the distance. And the number of gallons in that tank. So this picture right here has several things that are continuous that could have been chosen with that graphic. Now down here they do list some characteristics that they might be able to figure that out, but again, the language is super technical. But what might be helpful is this. So you might direct them to be sure to scroll to the bottom and look at the graphs. That might help. So there's some more examples of discrete and continuous graphs, and they do have labels. So those labels are kind of important. Months and savings, customer and samples. These are things you count. Age and height. I don't know. Age and height can be discrete or continuous, but if you only have a few data points, maybe, I don't know, this isn't even a function, so I'm not sure how those labels make a lot of sense. And then ticket and cost. Now over here, these are things that are measurable: time and volume, time and temperature, age and height, pounds and cost, and so forth. And they give some more examples down here. And then that's it. So, in other words, when they go through here, there's quite a bit of information they could look at, but tell them the language is intentionally very challenging. So you're not really supposed to be paying too much attention to their language. It's the pictures, the graphs, and if they want to read the words, they can, but don't get frustrated if they're using language that you're not super familiar with. Now in the show notes, I did include this text and I wanted to point it out. So the kids need to make sure they are copying a picture or an image from the slide of something that is discrete, that is different from their teammates. So my teams only had 3 or 4 people, so you should have 3 different images for a team. So each team will have their own, each individual on the team will have their own, but the goal is to get them to really look at more than one quantity and talk about it with their teammates. It says, when you are finished, compare your choice with those of your team, and what do you notice? And then it says here, do not copy text from the site to answer a question. Use your own words. So they should be typing in their own words what they think it means to have data that is discrete, or quantities that are being graphed with a discrete graph. And then for number 9 is basically the exact same thing, except change that to continuous. So they'll go back to the same site, pick an image of something that's continuous, and explain why in their own words. Choose something different from your teammates, and at the end they'll compare what they choose, what they said about theirs with their teammates. All right, the last thing is kind of a little mini assessment to see if they got discrete and continuous figured out. And so they will go to GeoGebra, and it will open this little app, and it will give them an example. What is the length of your right foot? Well, if I was measuring a foot, I would measure it. I wouldn't count that. So that would be continuous. When they check their answer, it's going to say correct, or if they miss it, it'll say incorrect. They need to take a picture of one that's continuous. 2 pictures that are continuous and 2 pictures that are discrete. So they will go to the next problem, and they will continuous or discrete. So remember, countable things you can count, we say, are discrete, and things that are continuous, you can't really count them, but you can measure them. And so they'll take 4 pictures, and it says do 2 pictures of discrete and 2 of continuous. So they'll have to shrink them down to get them all on here, but they need to kind of make those images small, and they can put them here. And that is the end of the slides. So the last activity we're going to do is the Desmos Graphing Stories activity. So they say this needs to be at least 60 minutes, so this may be an entire class period too. So that's why I have 2 class periods. Maybe to do 2 or even 3 class periods. Maybe I should change my little guide there to say 2 or 3, but we have done quite a few activities with the sketching so far, so hopefully they've gotten a little better at it and will be able to do that. But on these, if you haven't seen them, lots of good show notes with good teacher questions and things to say and language to use. So you're kind of teaching them the vocabulary as they're participating in this. And so on this one, they're going to talk about what measurements are changing. So keyword there, we could actually use the words discrete and continuous as we talk through these activities, since we've defined those in the last part of the lesson. And then on this one, they're going to actually sketch it, and then lots of good show notes down here. So read teacher moves before you start this activity. They have linear They can use lines. They can freehand it with one of these. They can erase the whole thing by clicking this X, and there's the eraser if they just want to erase one little part. They can change the color, and they've used these tools many times before, so this shouldn't be new if you've been doing the other activities prior to this lesson. And then it goes on to do another one where it'll watch and answer. And so what this screen will do is it will pick an answer of another student in the class, and it will display it. It may be wrong and it may be right, so it doesn't have to be a right answer. But they can kind of look at what that other student has done and compare it to their own work and decide whether that's better or maybe theirs was better. Another thing I've noticed is some of our kids are not super familiar with meters. They just don't know what that is. So I have a meter stick in my classroom, and I have a yardstick, and I show them before we even start on these activities about what that is. I even give a meter stick to each team to use while they're answering these questions because it helps them have a reference. You know, how much exactly is a meter? How tall is this person? And how would you measure their height in meters? And they can measure their own height in meters. So I do give those out, and they use those whenever we're working with meters, especially early in the year because a lot of kids are not as familiar with that measurement. And this one has water going into a bowl, and then while the water's pouring in, another bit is poured in, and then they're going to sketch the graph of that. This one has the nice little vertical bar in here. It's so nice. It helps them keep track of the time. I think the first time I did this, I don't remember that being there. They added that later, but that's a super nice thing to have. Then we get to an egg carton. Well, hopefully, if they remember what we just did, it's a good chance to talk about discrete data and continuous data. Now, this is time in seconds, so it's kind of a mix of discrete and continuous. It's really like a step function, as you will see in a minute, but I'm not going to show you that. I want y'all to do it, but be sure you're reading these teacher moves at the bottom of these screens for additional support. Here's one where they're writing on the carousel, and the label says distance from the camera, so from your vantage point. And then they'll do it again with distance from the center of the carousel. So a different perspective produces a different graph. Then we go back through then it talks about the water episode with an example that it pulls from the students in your class. And then it pulls in eggs from a carton. You can always have a fake student in your class, I guess, and have them do really good ones if you need one to display. I've done that before, I must admit. If I had a class really struggling and I didn't have any good examples, I might create some and stick them in there and not let them know it. This is the distance from the center. They're watching other students' answers. All of these are watching answers. And then finally, they can create a challenge. So this would be eligible for their portfolio. So for the challenge, they will select one of the 4 stories: slide, water, eggs, and carousel, and they will change the quantities they are using to measure. So instead of for the slide, for example, I think it was height and time, you could count his steps or maybe his distance from the end of the slide or something like that. So that concludes our discrete versus continuous lesson. If you have any questions, y'all let me know on Twitter. Have a great day.